Hi, I'm Jeremy, and something I've learned is that farmers have to make a lot of difficult decisions every day, from when to plant to how to market and sell their product, and everything in between. One of the biggest decisions farmers have to make, though, is which variety of crop to put in the ground in the first place, because the variety that goes into the ground can have a huge effect on how that farmer manages that plot and how much yield that plot will produce. This is where my research comes in. I use computer algorithms to help farmers choose which varieties might do well on their unique farm. Historically, predicting crop traits like yield has been incredibly difficult because knowing which varieties will do well in which landscapes depends on many factors. This is because the problem is a lot like a puzzle. That is, some varieties do well in some landscapes, but not so well in others. Just like how certain puzzle pieces fit to a given place better than others. Scientists have had a lot of success though in predicting and improving crop traits using genetic data alone. People like to think of this data as the DNA blueprint for how an organism might look and grow. In fact, this concept of using genetic data to predict crop traits is so widespread that researchers often refer to different varieties as their different genotypes. But you might be thinking, that can't be the full picture, can it? And you'd be right. Because there's also the environment, which we know varies from farm to farm and even from plot to plot. The environment can have a huge effect on how well a given variety might do. And researchers have been successful at improving their accuracy of predicting crop traits by combining genetic data with environmental data. We even have a name for it. We call this interaction a genotype by environment interaction. My research, though, investigates yet another layer, the microbiome. You might have heard of the human gut microbiome and how it affects your health by helping you digest food and absorb nutrients. A plant's microbiome is similar and can affect its health too. And some varieties are better than others at recruiting so-called beneficial microbes from the environment. I like to think of these as little supermicrobes that perform functions for the plant, such as suppressing disease or making more nutrients available, which in turn improves yield. Therefore, knowing which microbes associate with which genotypes in different environments helps us see the bigger picture and allows us to make more accurate predictions. We call this interaction a genotype by environment by microbiome interaction. Clever, I know. However, by combining these three datasets using predictive computer algorithms, we hope to be able to more accurately predict how certain varieties will perform on a plot-by-plot basis. And by doing so, will allow us to see a more complete picture of the landscape, and ultimately help farmers make better decisions. Thank you.